All right there. Hello, everyone. So, today's lesson we are going to be looking at some circuit vocabulary. And this is kind of the basic foundational vocabulary that we are going to need throughout the rest of the semester. So, what I'd like you to do is to please take out your STEAM notebook, whether that is a spiral bound notebook or just a stack of papers stapled together, that's fine. Get it out, and we are going to first make a vocabulary table. And the first word we're going to look at is voltage. So voltage is basically just the energy that powers the circuit. So in our example that we did last time, we had two AA batteries, some tin foil, and an LED. So in that scenario, the voltage was being given by those batteries. The batteries provided the energy. So the symbol for voltage is the big letter V. And we measure voltage in volts. So here's some examples. The AA batteries that we used yesterday, those each contain 1.5 volts. Okay, 1.5 volts in a AA battery. A car battery, if you've ever seen one of those, are a huge battery, that contains 12.6 volts. So we need more battery power to turn on our car. And when we go home or when we're at school and we plug something into the wall outlet, that provides 120 volts of electricity. So that is one of the reasons why you don't want to stick your fingers in those sockets, because that is a ton of volts running through our bodies. All right, we're back to our vocabulary table, and we're going to talk about the next couple words. The next word I'd like you to add to your table is current. And the current is the speed at which electricity is flowing through a circuit. So I like to use the analogy of a garden hose. And if you turn on a garden hose and there's no bend in it, water just flows through it really quickly. So we would consider that flow, the speed that it's flowing, that would be the current. We use the letter I, the capital I, for current. Don't ask me why. Doesn't make sense, but we don't use C, we use the letter I. And it's measured in amps. Okay, current is measured in amps. So if we want to measure the current of a circuit, there's actually something called an ammeter that we would attach to the circuit, and it would tell us how many amps, how much current was flowing through the circuit. Okay, the third word is resistance. Now, resistance is kind of just like it sounds like. When you think of resistance, you think of stopping or wanting something to stop. And that's kind of what it means. Resistance is slowing the flow of electricity. So it slows. We use the symbol R, we use a capital R for resistance. And resistance is measured in ohms. And there's that funny Greek symbol that we read that as an ohm. Okay, so back to the garden hose analogy. Let's talk about resistance with our garden hose. Okay, remember, resistance slows the flow of electricity. So if we picture a garden hose, normally the water flows freely. It'll just shoot out of the hose easily. So that would be a hose with no resistance. There's nothing stopping the flow. And in that case, the current would be really high because the water is moving quickly through the hose. Okay, but if you look at the picture on the bottom right, this is like some resistance. When you put a kink in the garden hose like that, what's going to happen? Well, the water is going to slow down. It's not going to be able to move through the hose as fast. And on the other side of the hose, you'll just see kind of a drip come out of the hose. Okay, so resistance is like putting a kink in your hose and slowing down the electricity, which in turn drops the current. Okay, so those were the three vocabulary words that we're going to use. And now I'm going to talk to you about how we can apply those vocabulary words to some math. There was this genius named George Ohm who came up with a law that relates volts, current, and resistance. and he found that those three variables were all in proportion to each other. Pretty impressive. So Ohm's law is used by engineers and electricians every day when they're doing anything involving electricity. So Ohm's law is this. It is V equals I times R. Okay, V equals I times R, which stands for volts equals the current times the resistance. So now we can use this law. If we know the value of two of the quantities, we can use algebra to solve for the unknown. So why is Ohm's law important? Well, every component has a maximum amount of current that it can withstand and a minimum amount of volts needed to power it. So it needs a certain number of volts, but it can't have too much current running through it, because if too much current runs through a circuit, if electrons are moving so quickly, then the circuit can short and it can burn out components and it could even start a fire. So resistance is very important because it slows down that current, and we can use Ohm's law to figure out exactly how much resistance we need in order to safely attach components to our circuit. So I'm going to give you two examples of actually using Ohm's law to solve for an unknown value. So suppose we have a 9-volt battery and it's powering a circuit with half an amp of current, 0.5 amps of current. What is the resistance? Okay, we know two of the quantities. We know how many volts, we know how many amps, so we can use some algebra to figure out what is the resistance needed in this circuit. Okay, we're always going to start out the problem like this. We're always going to write V equals I times R. Then we're going to substitute numbers in for what we already know. We know we have 9 volts. We know we have 0.5 amps of current. So we get 9 equals 0.5 times R. Now is where we need to use algebra. Okay, since we are multiplying 0.5 times our unknown, we have to undo that action by dividing both sides by 0.5. Once we do that, we will find that R equals 18. So there would be 18 ohms of resistance in this circuit. Okay, example number 2. We have a circuit's resistance of 15 ohms and the current is 2 amps. So this time we're given the resistance and the current. We can use those two and Ohm's law to figure out how many volts. So once again, the first step is to write V equals I times R. Let's write our equation right away so we know where to proceed from here. Okay, we don't know how many volts, but we do know there is 2 amps of current and 15 ohms of resistance. So V equals 2 times 15, which is easy. No algebra required, just a little bit of simple mental math, and we get V equals 30. There are 30 volts powering the circuit. All right. So I hope you learned a lot today. I hope you learned about the 3 vocabulary words that we're going to be using, as well as how you can apply them to Ohm's law. Good luck on your circuit math problems, and I will see you later.